Welcome to another RokCoder tutorial, and in this tutorial I'm going to show you how to make a three-dimensional galaxy like the one you see in front of you now. And I'm also going to show you how to make it with just a few very short scripts. What you're going to need to do is go to the 3D Galaxy tutorial in the RokCoder tutorials profile, as you see before you now, and press the remix button. And the reason for that is this project contains the music that we're going to use, it contains the backdrop we're going to use, and it contains a handful of mathematical functions that we're going to use, because it is a three-dimensional project, so obviously there's going to be some maths involved. But we're going to look at that later. The first thing we want to do is to hide the thumbnail, as we don't need that. The backdrop is black, and so we're seeing a totally black screen. And we want to draw a galaxy on that screen. And to do that, I'm going to need to use pen functionality. And so, going to the bottom left of the screen, we're going to add an extension. We're going to select the pen extension. We're going to add that. And that's very handy for drawing stars. So let's get started straight away. Adding an event when the green flag is pressed. What we're going to do is we're going to set the pen up. All the stars we draw are going to be white. So we'll set the pen colour, click on the colour, drag the saturation to the left and the brightness to the right, and we'll have colour white. So we'll set the pen colour to white. We're going to set the size of the pen. I'm going to set it to 2. So drawing lots of small stars. And then I'm going to use a forever loop just to see when the mouse is pressed. So if I'm going to a sensing block, mouse down, then we're going to want to draw a star where the mouse is. So we'll use a motion block and go to random position. But if we click the drop down by random position, we'll see we can go to the mouse pointer. And when we're at the mouse pointer, we'll use a pen, and all we'll do is we'll put the pen down and lift it back up again, and that will draw a dot wherever the mouse goes. So if I run this project, it should draw dots as I move. Only when I'm pressing the button, I can move the mouse around, but when the button is down, I'm drawing a series of dots, or stars as we're going to use them. But because we're going to actually be rotating all of these stars in the galaxy around, we're going to need to store where each and every star is. And so I'm going to add a custom block. Let's just stop that running. And I'm going to make a block. I'm going to call it add star. And it's going to take 2 parameters or 2 inputs. The first input, x, for the x coordinate of the star, and the second input, y, for the y coordinate of the star. And so when the mouse is down, now we're going to add a star. And the x coordinate in the sensing block, we're going to use mouse x and mouse y for the y coordinate. So we don't need these other blocks now. We don't need to go to the mouse pointer. We're not going to draw it yet. We're just adding the star. And we're going to have to add the stars to a list. And so go to variables and let's make a list. The first list is for the x coordinates of the stars for this sprite only. And the second list is for the y coordinates for this sprite only. And so when we add a star, all we have to do is add, and we'll drag the x input over there. So we're adding the x input to the x list. And we're adding the y input to the y list. So all that's doing, we're not drawing them anymore, we're just storing the coordinates in the lists. And if I run that project, as soon as I press the button, you can see the lists start filling up very quickly. They're filling up, I mean, they've added 100,000 stars, but they're adding in that quickly because I'm not drawing anything, so it's going super fast. Now, if I stop the project and run it again, you'll see that all those stars are still there. That's not what I want. So it's always a good idea at the beginning of your project to make sure you've emptied all your lists. So right at the beginning, I'm going to delete all of X, and I'm going to delete all of Y. Just so that if I run the project now, I'm starting off with empty lists. And I also want another custom block. So I'll go down to My Blocks, Make a Block, and this one is going to be called Draw. And this one, I'm going to make sure you click the Run Without Screen Refresh, because this particular custom block is going to draw all the stars, and it's going to do it a lot of times. As the whole galaxy rotates, it's going to have to redraw the stars every single frame. And so we're going to do it without screen refresh so that it can draw them quickly enough. So we click OK, and I'll take that draw function down to here. And the draw function will have to make sure the screen is clear. And I'm going to make it a variable. I'm going to call it index. And I'm going to use this variable to go through each and every star in the list. So we'll start off by setting the index to 1, which is the first entry in a list is item 1 of that list. And I'm going to loop through every entry in the list. So I'm going to repeat the length of the X list. I could repeat the length of the Y list. They're both the same. Every time I add a star, I'm adding an X and a Y. So both lists are always the same length. So I'm going to repeat that many times. And each time I'm going to, for a motion block, go to, and the X coordinate is going to be item index of X. And the Y coordinate is going to be item index of Y. And then, as before, I've moved to that point. I'm going to put the pen down, and then I'm going to lift the pen back up again. And then I'm going to move on to the next star in the list. So I'm going to change index by 1. And so this, it's going to start, set index to 1, so it's starting on the first X and Y in the list, draw the star, go to the next one, and so on. It's going to loop until it's done every star in the list. So I'm going to hide the lists by unticking these boxes. I'm going to hide the index variable by unticking this box, and I'm not going to press execute yet because I'm not actually calling the function. I've made the draw function, but I need to add it to my main loop. So up here, so it's doing a forever loop. It's always doing this again and again, checking the mouse, adding a star if the mouse is down, and then drawing all the stars. Don't forget it's clearing the screen and then drawing all the stars and then doing it again and again and again. So if I run this code, I've now got a program that's let me draw the stars. And if I look at the lists, I can see that it's added all the X coordinates and all the Y coordinates, and I have 133 stars there. So that's a very simple little program that allows me to draw a 2-dimensional galaxy. But to make this a little bit more impressive visually, I'm going to add some symmetry. So if you consider I had a star there at the top right, and maybe I want it to draw other stars symmetrically. So maybe it would draw another one over here, another one there, automatically. So for this, I need to work out where that star is, the first star, in relation to the center of the screen. So it's there. Now I need to know the length, how far away it is from the center of the screen, and I need to know the angle that it's at from the center of the screen, because once I know that, I could, for instance, add 90 degrees to that angle and be over here, add another 90 degrees here, add another 90 degrees here. Or I could do 5 stars in symmetry, or 6 or 7. But to do this, I need to know where the star is in relation to the center of the screen. And that's where some of my maths functions come in. So let's go back. Well, let's stop it running. And let's go back to the add star function. So to work out the angle, I can use the custom block that I've already set up, angle equals a tan 2. So I'll put that right at the beginning, and I'll drag x into the x1, which is a second input, and y into the first input. And this will calculate this angle. And now I need to know the length of this line. And so I will use length equals length of line with x, and drag x in, and y, and drag y in. And now I know it's called a vector. I know this point in what is known as a vector, an angle and a distance. And to convert the angle and distance back into an x and y coordinate needs a little bit of trigonometry. So I'm going to remove these two, and what I'm actually going to add is a multiply. And it's going to be a mathematical function, so it says ABS at the moment, but I will change that to cosine or cos, and cos of the angle that I've calculated, angle, and multiply it by the length that I've calculated, length. And then underneath that, I'll do a similar thing. It's another multiply. This time, the mathematical function is a sine, again, of that angle, and again, multiply by that length. And so now all this add star custom block is doing is converting the original x and y point into an angle and a length, and then converting the angle and length back into the x and y coordinates. So it's going to do exactly what it did to start with, but I've learned some more information about it. So if I run this, it's effectively doing exactly what it did before, but we have some useful information we can use. So let's add some symmetry. I'm going to make a variable called symmetry for this sprite only. And this is going to be the number of points of symmetry. So right at the beginning of the project, I'm going to set symmetry. I'm going to set it to 4. And so for every 1 point I draw, it's going to draw 4 points on the screen. Now we know there are 360 degrees in a circle. So if I want to make it symmetrical for 4 points, then that's 360 divided by 4 is 90 degrees. So each point is 90 degrees apart. So let's add a variable called delta for this sprite only. And we're going to, after we've calculated length, we're going to set delta and use a divide function. We're going to set it to 360 divided by symmetry. So as I've just shown, if symmetry is 4, this is going to equal 90. So let's add those 4 points. I need a repeat loop, which I'm going to put around the adds that I already had. I'm going to repeat symmetry times, because that's how many points I want. So the first point is being added exactly as it was before. But I'm then going to change the angle, and I'm going to change it by delta. And so it's going to draw 4 points equally spaced out around a circle. And let's see how that goes. Let's run it again. I'll draw a dot over there, and you'll see I've had one there, and one there, all drawn automatically. So if I draw like this, I've got some nice symmetry going on. And not only that, but I can easily change this symmetry value. I'm going to make it 16. And I'm going to run the project again. And look now, 16 points. If you count them, there'll be 16, and they're all coming off symmetrically. So it's just a really nice drawing program and a really nice way to draw swirling stars in a galaxy. But I know you're thinking, well, it's still two-dimensional. Let's change that. A quick word on three-dimensional axes. Right, this, if you look at the mouse pointer, is your scratch screen. The x-coordinates go from left to right, and we call that the x-axis. The y-coordinates go from bottom to top, and we call this vertical axis the y-axis. And then there's one more axis that goes into the depth of the screen. If you put your arm out as if you're pointing in front of you, you are pointing along the z-axis into the distance. And we're going to rotate this around the y-axis. So the axis that points upwards, this line here, will rotate around there using the mass function I've already got. X, Y, Z equals the y-axis rotate, and it rotates a point by an angle. So where I'm drawing the stars, instead of just drawing them where we place them, we're going to be rotating them. So let's go to the My block and let's add in the y-axis rotate before the go to. And then we'll drag the item index of x and put it in the x-coordinate. And we'll drag the item index of y and put it in the y-coordinate. Just stop that running. And then z, how far away it is. We're drawing on the screen, so we're going to call that a distance of 0. As stars go into the distance, they will get the z-coordinate will get bigger, and as they rotate around and come towards you, they get smaller. When they're actually flat on the screen, we'll call it a z of 0. And the amount we're going to turn them, we'll call y rotation, which is for this sprite only variable, and I'll put that into there. So we need to set y rotation at the beginning. So in the green flag block, we need to set y rotation to 0. And then whenever it's drawn all the stars, we'll rotate it. So we'll change the y rotation by 1. So that's rotating it. And as it says, it rotates it and returns a new coordinate in x, y, and z variables. You can see that in the mass function. It's setting the x variable, the y variable, and the z variable, x, y, z. And so I've rotated it around, and now I will go to the x coordinate and the y coordinate. And let's see what that does when we run the project. I'll draw a few stars, and there they go, rotating round and around. So it's now three-dimensional, but note that wherever I draw, it's not actually drawing where the mouse is anymore. It's always drawing on a flat screen that's rotating. So that's not exactly what we want unless we want an entirely flat galaxy. We want, even though it's rotating, we still want the stars to appear where the mouse is. Now that's not too complicated to do. All we have to do is remember what the y rotation is when we're drawing. So let's make another list. And we'll call it y rotation for this sprite only. And at the beginning in the green flag, where we clear the x and y lists, just hide that list, and we'll also delete all of the y rotation. And now, when we add a star, not only do we add the cosine and the sine, the x and the y, we also add whatever the current y rotation is to our y rotation list. So we know how far it has turned when we add our star. And then in the draw function, where we're rotating by y rotation degrees, all we do is we change that to, let's get a minus function, and it's going to be item index of y rotation minus the y rotation. So it's remembered the angle it was when we actually drew it on the screen, and it's adjusting for that. So let's just run that and see what it does. And now you'll see it's turning, and it's still drawing where my mouse is, but it's no longer a flat galaxy. It's now got some depth. So that is a three-dimensional galaxy rotating around. So you've done some three-dimensional work. Now there are a couple of things we can do to make this look even nicer. If you imagine how you see things, if an object is nearer to you, your hand for example, if you put it near your face, it's very large. And as you take the hand further away, it looks smaller. Or a car going into the distance looks smaller as it travels away. And we can do the same with this display. We can make the stars that are nearest bigger and the ones that are further away smaller. So let's do that. If we go into the draw function again, and we take notice that we've calculated the x, y, and the z coordinate. And as I explained before, the z coordinate tells you how far away something is. So the smaller that value, the nearer it is to you, and the larger, the further away it is. Now I know that the distance from the center of the screen to the top corner is approximately 300. You can actually check that using the maths function, length. So if I just have a look, say length, I know that the right hand side of the screen is 240. I know that the top of the screen is 180. So if I just run that block and then have a look at the variable length, it's exactly 300. So the distance from the center to the top right is 300. That's the furthest away a star can be from the middle of the screen. And so using that information, when I'm drawing, I can set the size according to that distance. So, a pen block. Let's set the pen size. So we'll go to the XY and then we'll set the pen size. As I said, I know that Z is between minus 300 and plus 300 as it's travelling around. Somewhere between there. So if I have an operator, a divide, and I say Z divided by 100, instead of being between minus 300 and plus 300, it's now between minus 3 and plus 3. So if I take a minus operator and put it in there and say 3 minus Z divided by 100, the pen size will be between will be between 0 and 6. So let's have a look now. I'm drawing the stars. See, as they travel away, they're getting smaller, and the ones near it are bigger. And that gives a real impression of depth to this solar system. But there's one other thing we can do, and it's a subtle change, but it's nice. Let's stop that rotating, and we're going to make it so that when stars are in the distance, they're fading out, and when they're near you, they're solid. And you can do that using transparency. So another pen block will say set pen, and it says set pen color. We'll put that under set pen size, but we can drop down from color and we can change the transparency. And as I said, the Z value is between minus 300 and plus 300. So I'm going to use here as a divide, and I'm going to say Z divided by 5, which means that the answer of that is going to be between minus 60 and plus 60. Now the transparency setting takes a value between 0, which means a solid colour, and 100, which means totally invisible, and you can have any variation between there. So the bigger the number up to 100, the more transparent it becomes. And so if I add a plus sign in there, and drag that into there, and if I say 50 plus Z divided by 5, that's actually going to give me a range between minus 10 and 110. Now, 100 or above is totally invisible. 0 or anything smaller, down to -10, is totally solid. So now stars that are in the distance will become invisible, and as I come to the front, they become solid. So let's have a look at that. Draw this, and you'll see that they're getting smaller into the distance, but they're also fading away. And that, I think, gives a beautiful impression of depth. So we have a 3D rotating galaxy. And there's only one more thing, well, there's a few more things I want to do with this, but one thing is to, instead of have it just rotating like that, is to tilt it slightly. So let's stop that going, and now I'm going to tilt it on the z-axis. So instead of rotating around the y-axis, which is totally straight up, it's going to be rotating at a slight angle. I'll show you what I mean. I'm going to get another variable, and I'm going to call it tilt, because this is how far I'm going to tilt it. And I'll set that variable. I'm going to tilt it at 30 degrees. So right at the beginning, set tilt to 30, and that's in the green flag block. And now to show that tilt, I'll go back to my draw function. And first of all, I rotate it around the y-axis, as I'm already doing. Then I go to my blocks, and I'm going to get the function to rotate it around the z-axis. And I'm going to take, as the x, y, and z, I'm going to use the variables x, y, and z. So first, it gets the x and y coordinates out of our list, and it rotates those around the y-axis, giving us a new x, y, and z. And then it rotates that x, y, and z around the z-axis by tilt degrees. And I'm setting tilt to 30. You can set it to what you want. You can play around with that. But let's have a look at the difference, and I think this makes it really nice. Now when I draw it, it's rotating around at a tilted angle, and I think that looks rather good. But notice again, it's not drawing it where my mouse pointer is, because again we've tilted it by 30 degrees. And so I need to counter that for where the mouse pointer is. So in add star, all I have to do is, where it's calculated the angle to the mouse pointer, after it's calculated it, I will just change that angle by minus tilt. I'll take tilt back off it, and that will counter the tilt. So the operator is minus 0 minus tilt. And now it should draw where my mouse is. So even though it's tilted, I'm countering that. I'm still able to draw where my mouse is, and it's rotating around. It's getting slower because let's see how many stars it's drawing at the moment. If I have a look at the x-coordinates, it's actually got 3,360 stars in that galaxy. That's a lot to calculate. But if I refresh it with an empty galaxy, you can see it runs really nicely. So spinning around at an angle. I'll wait for it to go until it's straight on, and I'll add some more stars on the edge. And there we go. And just as a finishing touch, I'll go to backdrops. And let's have a look at the backdrops. You see, I've got the black one that we're using, but I've also got Cosmos. So let's select the Cosmos. And there, that looks like a galaxy. But it's a little harder to see the stars now because it's quite a bright background. So let's have a look at the code in the backdrop. And what we can do is we can dim down the background. And I can do that very easily. I'll just have a green flag event. So when I start, I'm going to change the brightness. So it's a lux. I'm going to set the brightness, and the brightness is between -100 for black and 100 for white. So normally it's a setting of 0, that's the default. I'm going to set it to -30. Just by clicking this block, you can see it's got a lot dimmer. You can still see it, but now the stars stand out again. But I'm going to do something else to make it look really nice. I'm going to have a forever loop. And in that forever loop, going back to the lux block, I'm going to change the color effect. Now, if I change it by 1, and again, I'll click the block to set it running, you'll see the background is actually changing color all the time. It's going quite quickly. It's going quicker than I'd like, so I'd like it to be a subtle change. So instead of changing it by 1, I'll change it by 0.1. And now it's going to change much, much slower. And one last thing is I'd like some music. And I'd like the music to loop. So when it finishes playing, I'd like it to go back to the beginning. So how can we do that? I'm going to do this with a broadcast. So when I receive, and I'm going to have a new message, and I'm going to call it music. And this is going to run in a forever loop. And all it's going to do is in sound, it's going to play sound until done. Now it's important to use that and not the start sound. If you did start sound, it would start the sound, then it would loop and start the sound again and loop. You'd end up with it, well, it would just play the same music thousands of times and you'd end up with a crackling mess. But if I do play sound until done, and I've only got one sound effect in here, it's the music, it's going to play it until it's completely finished, and then it will loop and play it again until it's completely finished. So the music will just carry on looping forever. And I need to start the music, so when the green flag is pressed, I'm going to broadcast, not broadcast and wait, because if I broadcast and wait, it's going to broadcast down to here, and it's going to wait for this to finish, but it never finishes because it's in a forever loop. So it's just a broadcast. I'm going to broadcast music. And now, when I run the program, I'll just check I've got volume on, and I have. So when I run it, you've got a nice galaxy, you've got some music, and the galaxy is slowly changing colour, and I can add my stars to the galaxy. But I've noticed that when I'm drawing the stars, it's feeling a bit sluggish, and I know exactly why that is. If I go back into the galaxy sprite and have a look at the add star custom block, since we originally wrote that, I've added a loop to it for the symmetry. So we'll right click on it, hit edit, and make it run without a screen refresh. It's often a good idea to run loops, not forever loops, but normal loops in custom blocks, such as a repeat with no refresh. And now, if I run the code, it's running nice and fast. We have music, we have stars, we have a beautiful galaxy. If you wanted to, you could display the symmetry variable. You could right click on it, change to a slider, again right click on it and change the range so it's between 1 and 32. And then we can maybe reduce it down to 3 and just do a symmetry of 3 for a little while, and this will be clear if I rerun it. And I'll start with a symmetry of 2. I'll just do a few stars like that, and then I'll have a cluster of stars in the middle, so I'll have there, and then I'll drop it down to 9. So, and you can play around with the symmetry. You could play around with the tilt in a similar manner if you wanted. Right click on it, change to a slider, and you can adjust the tilt. So there's a lot of things you can play around with now you've got the galaxy working. We'll go into full screen, restart it, and just have fun. Just make some galaxies that you like. Just play around with it. It's very relaxing. So I hope you've really enjoyed this tutorial. And if you have, don't forget to like the tutorial, share it with your friends, and don't forget to hit the subscribe button so that you find out when more tutorials are released. And I'll leave you playing with your galaxies now, and see you again next time.